Ayan. So at the end of this module, you should be able to define and contrast the method of indirect from other kinds of proof. In our case, all you have to do is to differentiate the direct and indirect proof. Prove mathematical statement by indirect proof. So by definition, proofs make use of an axiom, a postulate, a previous proven theorem, or any allowable construction. There are two kinds of proof, no? The direct proof and the indirect proof. The method by indirect proof is sometimes called the proof of contradiction. So other term for indirect proof is the proof of contradiction. The indirect proof is basically done by assuming the conclusion to be false. Then, in the process of arguments, it leads to a certain contradiction, that is, contradicting the hypothesis, or maybe some contradictory result arises. So, recall natin, in direct proof, we have to assume that our hypothesis is true, no? Our hypothesis is true. But in indirect proof, will be negating our hypothesis and assume that this is true. Therefore, our original statement, yung hypothesis natin will be assumed as false. Nakuha nyo? So let's, I'll be giving you example for you to better understand what I'm trying to say. So the steps to follow in proving indirectly are assume the opposite of the conclusion. Yeah, the opposite of the statement. Proceed as if this assumption is true to find the contradiction. So, in-oppose natin yung conclusion, should be the conclusion. And i-assume natin that the opposite is now the true statement to find the contradiction. Once there is a contradiction, the original statement is true. Now, if we have proved na contradiction yung assumption natin, then our original statement must be true. Do not use specific examples. So same with our examples natin in proving the closure property where we just use variables. In here, don't use specific examples. Do not assume specific values of x or specific values of a and b. Use variables so that the contradiction may be generalized. So to start with, let's recall first our direct proof. Now, if you remember, I showed, we discussed how we prove statements using direct proof, no? That is with the use of the no-show table. If you remember the no-show table. So this is the statement. If x is an odd integer, then x squared is an odd integer. Okay? So that is a statement. So how did we solve this particular statement? If then statement, no, let's try to recall then yung logic natin. If then statement. So, recall natin yung truth value ng conditional statement. Recall natin. Kailan nagiging true yung buong conditional statement natin? And kailan nagiging false yung conditional statement natin? Who can share? Walang tahimik ngayon ng BS Math 201.
Sir, ulit po ng question. Medyo kami po dito eh.
Who can recall the truth value of conditional statements? Diba there were 4 possibilities there. Ano yung truth value for each possibility, or when we'll be having a conditional statement na true and when we'll be having a conditional statement na false? Wala na. Wala, nakalimutan na ata. Truth
Sir, kapag
value.
yung,
Yes. Charmaine. Charmaine ba yun?
pag yung pangalawa po, false.
Pag yung pangalawa is false. What do you mean by pangalawa? Be specific, no? Yung statement natin, meron tayong antecedent at consequent, di ba?
Sir,
So,
pag
alin
yung
doon?
pangalawa, pag yung pangalawa false, dun lang siya magfo-false. Dun sa final.
Kapag yung consequent natin is false, magiging false yung buong conditional. Ganun ba yun?
Opo.
Okay. So, if the antecedent is true and the consequent is true, the whole conditional is true. If the antecedent is false and the consequent is true, anong mangyayari?
Giging true.
True pa rin siya. True siya. But if our antecedent is true and our consequent is false, dun siya magiging false. And if they were both false, true pa rin yung ating ano. Tingnan natin. I think there must be wrong with your statement. Verify natin, no? Kunin ko lang yung logic natin. Text. To verify your statement, I have here the lecture. Truth table ng condition. Ayun. So it have turned out na tama yung makita ko lang may screen. So recalling our truth value, nakikita yung screen ko. Yan, ng conditional statement. So we have statement P and Q, or the antecedent and the consequent. First part is the antecedent and second part is consequent. And take note, there were times na magkabaliktad yung position ng antecedent and consequent. So you have to be specific dun sa second and sa first, in assuming the first and second. So dapat may term sila, the antecedent and consequent. So if our antecedent, if same yung truth value ng antecedent and consequent natin, magiging true sila. If they were both true and they were both false. But in here, if our antecedent is true and our consequent is false, dun na magiging false yung ating conditional statement. So kung babalikan natin yung... So ang i-assume natin dito is that our hypothesis is true. No. Now, if our hypothesis is true and na-prove natin na yung conclusion natin is true, then the whole compound statement is true. But if we disprove this conclusion, ibig sabihin, yung buong buong conditional statement natin is false. So we're trying to prove that this is either true or this is false, assuming that our hypothesis is true. Dun yung direct proof natin. So our line would be, of course, we'll start with our hypothesis na stating that x is an odd integer. Assuming this is true, what would be the conclusion? So, recall natin the definition of odd number. So, there exists a p element of integer such that x is equal to 2 plus p. So, yung definition natin for odd number is 2p plus 1, sorry. X is equal to 2p plus 1. Okay. It is by definition of an integer. Now we're trying to find the square of x. No? We're trying to find the square of x and then looking whether its square is an odd or an even integer. So, try natin yon. Squaring our x variable means that we have to also to square our definition ng odd integer. Okay. So, squaring both, palakihin ko, medyo maliit pala yung screen. Ayan. Ano ba siya? Ayan. And then, basic algebra, application of algebra. We have square, we have 4p squared plus 4p plus 1. We have 2p squared. I'm distributing 2 here. So that will be following the definition of odd. So 2p squared plus 2p plus 1. And then we'll assume 2p squared plus p as another variable q. No? And q here is also an element of our integer. So if q is an element of integer, we can now say that the square of x is also an odd integer by definition. No, nagtali yung definition natin. So therefore, we come up with our conclusion na ang x squared, the x squared is an odd integer. Therefore, we can say that the whole statement is true. So if x is an odd integer, its square is also an odd integer. That is by direct proof. So paano naman kapag indirect proof? That it has proven that if x is an odd, then now let's try to prove a statement or a proposition using indirect proof. So this is the statement that if the square of an integer is n, the square of an integer n is even, then n itself is even. Natin. If the square of an integer n is even, then n itself is even. So paano yung line of proof natin? So our hypothesis is this. N squared is an even integer. So yung i-oppose natin actually is this. Yung conclusion natin. N itself is odd. So parang mag-limit tayo sa gitna, no? So sa no-show table natin. Mag-limit natin si no and si show natin. Yan. We are to oppose our conclusion. Or that is not Q. In symbol. Okay? Sunod guys. Nyo Okay, so our conclusion is n is an even, right? So its negation would be n is an odd. Okay. So,
dito po sa part,
yes.
Dito po sa part ng 2 multiply by 2k squared plus 2k, di ba sir, isa-substitute yun para makuha mo yung 4k squared plus 4k, tama po?
This one?
Dito sir, sa medyo sa taas po. Yung yan sir, yan.
Wait lang.
Yung 4k squared plus 4k plus 1.
So, ang nasa table, ang nasa solution nyo, mag-start kayo dun sa hypothesis P and dun sa conclusion Q. No? So, bali, mag-meet kayo at the middle. So, at first, wala pa to. So, dun sa conclusion now, there's no entry for these tables or these columns and rows. So, pag-meet natin yung hypothesis and conclusion natin. From there, By definition, the definition ng even, no? N squared is an even integer. So by definition, N squared is 2p. So there is p is an element of z. So there exists a n squared, which is equivalent to 2p, which is an even, definition of even. And then we're trying to extract n in its to square root, hirap sabihin. To extract n squared in its second root or square root. Okay? So, gagawin natin yon. We have element PQ and PQ element of Z. So, these are integers then. So, n squared is equal to 2p. Hindi. So, it happens to be na we cannot yet prove this, no? So, magba-backward tayo. Backward yung solution natin. Kasi there's no way we can say that 2p is not equal to 2q here from this statement. So backward tayo. Backward. So from the conclusion, n is an odd number or odd integer. By definition, there exists k, an element of z, such that n is equal to 2k plus 1. So from there, from our n, we'll be squaring n. No, backward. So value from show tayo, from show. So we'll square n here. So squaring n, we have 2q plus 1. Ayun, ito pala. Squaring n here, we'll be having this 1. Nakuha nyo? Backward yung solution natin na from, we'll start with our show or in our conclusion. So squaring n here will give us 2k plus 1 squared. And by algebra, we'll be having 2k squared plus 4k plus 1. Undistributing 2, we'll have 2k squared plus 2k plus 1. And from there, let 2k squared plus 2k as q. Diba? So, papalitan natin yung 2k squared plus 2k ng q. Therefore, ang n squared natin is 2q plus 1. Which is not, no? Kasi, from backward solution, we're trying to prove that our n squared is uneven. No? We're trying to determine or to prove that n squared is uneven. Pero yung nakita natin from our backward solution, n squared is odd. Diba? 2q plus 1. So, from there, we can say that we have elements PQ, element of integers, na yung n squared natin, which should be uneven, pero it turned out, based in our solution, is an odd. So, hindi nagtali, hindi equal yung solution natin dun sa gusto nating i-prove na even. Therefore, if that's the case, contradiction siya. No? Contradiction siya. Ibig sabihin, if we found contradiction from between our hypothesis and our conclusion, therefore, our original statement must be true. No. So this statement must be true, or this proposition must be true. Nakuha nyo? Hello? Feedback?
Okay naman, sir.
Okay po.
Okay po.
So, huwag tayo sa second.
Tulito.
Medyo nakakalito lang. So, n squared should be even. It turned out it is odd. Gives a contradiction to the hypothesis. Thus, our assumption, kita ko lang yun. Our assumption, thus the assumption is false and so the conclusion is true. So try natin ng ibang example. Okay, this one. If x is an odd integer, then x squared is an odd integer. So somehow pareho lang siya dun sa taas, no? But then we'll try to prove this using indirect proof. So again, we'll be negating our conclusion and assuming that its negation is true. No. So ang negation ng x squared is an odd is x squared is an even. So, tignan nyo ulit kung kaya nyo i-solve backward or forward. Titignan natin kung forward siya or backward. So, from here, no, magkakaroon tayo ng complication if we take its square root, x squared. No. Kaya, mag-forward solution tayo from here. Forward yung solution natin. So, from our hypothesis, x is an odd integer. So, by definition of odd integer, we have 2p plus 1. Squaring x will give us 2p plus 1 squared. So, by algebra, we'll be having x squared is equal to 2q plus 1. So, yung x squared natin is 2q plus 1, which is odd. We're trying to prove that x squared is an even. So there is a contradiction again. We are contradicting our conclusion. Kanina, we are contradicting our hypothesis. Okay? So basta may contradiction between hypothesis and conclusion. Ibig sabihin, our assumption is now false. Which also mean na our original statement or proposition is true. Okay. Nakuha na? So, move pa tayo. We still have 4 minutes.
Sir,
Yes.
minutes na lang po.
Yeah. 5 minutes. Next. I think one more example. If x and y are odd integers, then their sum is an even integer. If x and y are odd integers, then their sum is an even integer. So we'll be negating this conclusion. Their sum is an even integer. Its negation is, what is the negation? The sum is odd integer. So, ito yung table natin. So the negation of our conclusion, or, yan, tama, is x plus y is an odd. And then, ito yung hypothesis natin. X and y are odd integer. Now, tignan nyo kung forward or backward kayo, no? Tignan nyo. If you'll be solving the state or the proposition backward, how would you come up, how will you prove na yung sum nito will be odd? No? Yung sum nila will be odd. So there must be complication, no? Whereas if we will be proving this forward, there's no problem. Kasi all you have to do is to add these two integers, x and y. So, ibig sabihin, mag-forward tayo. No? So, from here, there exists pq elements of z so that x is equal to p plus 1. This must be y. This must be y. X is equal to p plus 1, y is equal to q plus 1. And adding this x and y will give us 2p plus 1 plus 2q plus 1. And then by algebra, we'll have this statement. 2 times p plus q plus 1. And then we'll assume p plus q plus 1 as another variable, r, which is element of z, or an integer then. So we have now x plus y is 2r. Ibig sabihin, when we add two odd number or odd integers, our result is 2r. And again, there is a contradiction. It contradicts our assumption na their sum is odd. So, ibig sabihin, our assumption is false. So our conclusion in the original proposition is true. Sum is even. Okay. So ayun. Any question? Basahin nyo lang yung other examples. If you have questions regarding this example, then I could isa na lang pala yung naiwan eh. Babasahin nyo lang siya, and then kapag may question kayo, just ask sa group chat natin. And then I'll be posting our exercise too later. So these are the examples or yung mga kailangan i-prove. So if there's no question, let's call it a day. Kailangan mayroon na chat. Tignan mo lang basahin ko. Basahin na lang din po ng video. Okay, any more question?
None so far, sir.
So that's all for today. Thank you for listening. Bye, class.
Good day,
Bye,
sir.
Good day.
Hey, sir.
Good day po.